Why is smell, often called the Cinderella sense, so underrated in our culture, especially when many luxury products, like wine, spirits, and perfume, are based on it? Even though dogs have twice the number of scent receptors than humans, why are we better at detecting wine aromas? What might surprise you about how we perceive the senses of taste and smell? And why is the sense of smell so evocative compared to other senses? In today's episode, you'll hear the stories and tips that answer those questions in our chat with Johannes Frasnelli, a physician and a professor focused on the sense of smell. By the end of our conversation, you'll also discover the most surprising things Johannes has discovered about our sense of smell in his research, how our olfactory anatomy and processing of smells actually work, the difference between taste and flavor and how they work together, how men and women perceive smells differently, and how expectations and language can influence our smell perception. Do you have a thirst to learn about wine? Do you love stories about wonderfully obsessive people, hauntingly beautiful places, and amusingly awkward social situations? Well, that's the blend here on the Unreserved Wine Talk podcast. I'm your host, Natalie McLean, and each week I share with you unfiltered conversations with celebrities in the wine world, as well as confessions from my own tipsy journey as I write my third book on this subject. I'm so glad you're here. Now pass me that bottle, please, and let's get started. Welcome to episode 311. I wanted to share some personal news with you as I recently received the judges' comments from the 2024 Ottawa Book Awards, for which Wine Witch on Fire, Rising from the Ashes of Divorce, Defamation, and Drinking Too Much was a finalist in the nonfiction category. Quote, wine writer Natalie McLean details her experiences in the wine industry, from exquisite tastings to unsettling misogyny, in this memoir driven by rollicking prose and grit. She is vulnerable and unrepentantly flawed, but with the grace to admit to any professional blunders. She also navigates divorce, dating, and home life. McLean is enormously skilled at pacing and structure. Her voice, which is lively and conversational, does not belie her extraordinary depth of knowledge. End quote. Well, that's just the kind of report card my mother loves, and I did send that to her. But I also wanted to share it with you as you've been on this journey with me, and I really do appreciate your support. If you're reading the paperback or ebook or listening to the audiobook, I'd love to hear from you at natalie@nataliemclean.com. If you'd like to give this memoir as a holiday gift, I'd be happy to send you personally signed book plates, both for yourself and for the copies you give as gifts. Heck, I'll even recommend wines to pair with it if you want to do like a bottle and book gift set. I'll put a link in the show notes to all retailers worldwide at nataliemclean.com/311. In other bookish news, I have one copy left to give away of Tony Edwards' new book, The Very Good News About Wine, as well as one copy of Gus Sue's new book, Behind the Glass, The Chemical and Sensorial Terroir of Wine Tasting. All you have to do is email me and let me know that you'd like to win. I'll choose 2 people randomly from those who contact me at natalie@nataliemclean.com. I've had a lot of emails and direct messages about these episodes in terms of their content, so I'm glad that you enjoyed them and found them both surprising and illuminative on their topics. Okay, on with the show. After being trained as a physician at the University of Vienna, Austria, Johannes Frasnelli was a visiting scientist in the research labs in Philadelphia, Dresden, Germany, Stockholm, Sweden, and Bozen, Italy. He is currently a professor of human anatomy at the University of Quebec at Trois-Rivières, as well as a regular researcher at the Research Center of Saint-Cœur Hospital in Montreal. His research focuses on the physiology, the psychology, and the pathology of the sense of smell. And he joins us now from his office in Montreal. Welcome, Johannes. It's so great to have you here with us.
Thank you for having me.
All right, great. So before we get into all of these juicy topics, what was your earliest, most memorable sense of smell? Like, how old were you and what was it?
Yeah, I had the chance to grow up in a very beautiful part of the world. I grew up in the north of Italy in the Dolomites, and I remember that the seasons all came with a very distinct smell. I cannot say this one was the first, but of course we had all the smells around Christmas time, the cloves and cinnamon and so on. And then later on we would have the different smells that were associated with Carnival, and then we would have the spring with apple flowers and so on. And the whole year round, every month, every season came with a very, very distinct smell. When I go back home now in the different seasons of the year, I can still smell them, and it really brings me back to my childhood.
That's lovely. Very Proustian, as we all know, that beginning of time lost, remembrance of time lost. I'm sure you've had this put back to you all the time, but it's actually not the taste of the cookie, but the smell of that Madeleine cookie that sets off all his memories. But so, when did you first become fascinated with the subject of smell, the science of it, to study it?
This is also quite, well, I think interesting story. When I was a student in Vienna, so I moved away from small town Meran in north of Italy and went to study when I was 18 years old, and I went to the big city in Vienna. Vienna has a tradition of having those outdoor markets where you can whole year round you can get different kinds of foods and vegetables, but also spices. And there's a lot of people from Turkey, from the Middle East that are selling their products there. And this was for me a lot of new smells, a lot of new tastes and new flavors that I kind of organically learned there. We would go there on Saturday and get our stuff, and it was much cheaper than the rest. And in parallel to that, I did my studies. And at some point, towards the end of my studies, I had the opportunity to do a medical doctoral thesis, which is not at all like a PhD thesis, much smaller. And I thought, oh, that's interesting. And the topic was the sense of smell in people with chronic kidney disease. And I came from the kidney side, actually, but I thought, oh, wow, the sense of smell, we can actually study that too. And all of a sudden, I realized that I'm about to combine that, what's interesting for me in my private life, in my personal life, with what is interesting for me in my professional life. And I started out with that. I did not have the intention to do that for the rest of my life. But then as the year went by, at some point I realized I am much more interested in the sense of smell than I'm interested in medicine. So I went on with that.
So you made a bridge there. That's fascinating. And what's the most surprising thing that you've discovered about our sense of smell in your research so far?
In the very beginning, what I was very surprised about is how little we know about the sense of smell. So this was, I would go back 1999, 2000. And I think over those last 25 years, a lot of things have happened. A lot of things have happened also with the sense of smell. So the first surprising thing is how little we know. And then the next surprising thing was in 2004, when a Nobel Prize was attributed for the discoveries on the sense of smell. That was then also a surprising thing, of course. And later, COVID came around. It was again surprising that the sense of smell is so central in the early screening for the disease and is so heavily affected. And it was also surprising before we talked about COVID is how many people suffer from a smell dysfunction. It's approximately 20%. This is before COVID
Wow.
came around. And then I think the next surprising thing is how little people were aware of that. And then once COVID hit and people would become more aware about it, then it was surprising how interested and fascinated the whole population would get with regards to the sense of smell. So from not knowing anything to being very aware of the importance of the sense of smell.
Yeah, it's been a whole cultural change for sure. And I know in the wine and food worlds, it's become important. I see profiles all the time of a certain chef or a sommelier lost their sense of smell due to COVID. Most of them were happy stories in the end. They got it back, but we're going to dive more into sense of smell and disease because that is just fascinating. If there's one myth that you wanted to debunk or dispel about our sense of smell, what would that be?
Well, I think the most central one, and I guess the people listening to us know about that, the most central one is that once we have something in our mouth, we talk about taste, but it's actually not taste, most of it, what we perceive, but it's olfaction, it's retronasal olfaction as the odor molecules enter the nasal cavity from the back door through the pharynx, through the throat. And what we can taste with our tongue is sweet, sour, bitter, salty, and umami, and all the rest is actually olfactory perception.
Hmm. Yeah, absolutely. Why do you think smell is underrated? Why, of all the, like, sight is the think you've said it or somebody said it in an interview with you. It's the sense of science. It's highly respected. It's cerebral. Why does smell get a bad rap? Is it because it's so animalistic or base?
I think there's definitely something to it. There's a very interesting paper that came out 5-6 years ago by John McGann. He described there's a myth about us not having a good sense of smell compared to other animals, and I think we're going to talk about that later. But this has its roots in the 19th century, where the whole Darwinian ideas came up and became more important. And all of a sudden, we were just another animal, not this creation of God that stands out. And so different players, including the Catholic Church and so on, had to make sure that we are different from other animals. And so we would look at what does make the human. They looked at it. What makes the human human? Well, it's sight, where we can read with it. It's language, where we can talk. So it's audition. So these senses, of course, they're very developed for us humans, but these senses were the senses that we distinguish ourselves from the animals. And the other senses where animals may be outperforming us, well, these are then lower senses. The consequence of this is that we A, thought this is a lower sense, and B, this is less important for us. But as a secondary result of this is that we as mankind would put much less effort into understanding how the sense of smell works, because that's something that was reserved for rats and dogs and other species like this.
Right. So less research dollars and so on, when it's yet still so fundamental to being human. There was a really interesting study with graduate students, I think, who are given a choice between their sense of smell and their phones or something like this. Maybe just tell us what that study was about.
I think it was Rachel Hertz who did this study where graduate students were asked what they would give up for some item. So it was shown that they would be very hesitant to give up a vision for their cell phone. If they had to choose between keeping their cell phone and keeping the vision, then they chose vision. But if they got the option to give up smell or the cell phone, then the choices were quite different, and the participants were quite ready to give up the sense of smell. This is one study, but this is consistently found when we ask people what is the most important sense and which is the least important sense, which one would you give up if you had to, and so on. The sense of smell always comes up last. I think this may change a little bit, or this may have changed with the context of COVID, as we already discussed, where beforehand, people that have lost their sense of smell, they really were exotic. Nobody talked about it, although it's very widespread. But, if somebody said, I cannot smell, then the other said, well, you're lucky you can't smell, the people in the bus or the diapers or whatever. But I think there was all of a sudden much more awareness how important it is to have a good sense of smell. And now, of course, this audience knows it very well. But I think this is a common misconception that the sense of smell is less important than it actually is for us. Because it's not just smelling flowers and so on, because the sense of smell has much more implications. And I'm sure we will be talking about that as well.
Absolutely. I'm fascinated with this. Even in something like as simple as a tomato, there are 200 odors. We're going to get into this. So first, though, let's walk through how smell works. You started on this, but what's the basic anatomy from odor molecules in the wine glass? How do they get up to our brain?
Yes. So first, we need to have an odor source in which the odor molecule is stored. So this can be a liquid like wine. This can be a solid substance. This can be gas. From this odor source, the odor molecules have to reach the air. So they have to be volatiles. And they can reach the air either by evaporation or because it is heated up or whatever. Then they are in the air surrounding our body. They can be also inside our body if they are in the mouth. And as we breathe in, actually what happens is I contract the muscles of my diaphragm and I create a vacuum or under pressure in my lungs, and then air is sucked in to counter that. And if my mouth is closed, the air goes through my nose. And with this air, all the molecules that are found in the air, and not just the odor molecules, also viruses and bacteria and dust and whatever, will come into our nose, will be filtered. And the odor molecules will reach the upper portion of the nasal cavity, really the roof of the nasal cavity. And in this portion of the nasal cavity, we have a specific epithelium. We have specific cells in the mucosa. And these cells, the odor receptor cells, have on their surface receptors, olfactory receptors. If the odor molecules fit to this olfactory receptor, then something happens in the chain, in the cell, a chain reaction of things happen. And the end result of that is that the so-called action potential, an electrical signal, is created in the olfactory receptor cell. And this electrical signal is then conveyed via the olfactory nerve into the brain, into the olfactory bulb that's located above our eyes, between our eyes and above it. And from there, then we have different other processing steps until the information, now this is now an electrical information, this is not the odor molecule anymore, will then reach the centers of the brain that are responsible for processing and for perception of olfaction.
Wow. And what about the trigeminal nerve? Is it involved in this smell and
Yes.
wine tasting?
So per se, smelling is limited to what I just said. Of course, the odor molecules that we have, and not just the other molecules, other things that we could find in there, they may stimulate other receptors of our body, other organs of our body. And for example, if we have wine in our mouth, the same thing happens that I just said before. So volatiles will come out of the liquid and then be in the air and reach the nasal cavity. But of course, also the liquid in the mouth will stimulate the receptors in the mouth, the gustatory receptors. So it will be sour, it will be sweet. But it will also stimulate the alcohol, for example, has a smell, but the alcohol will also activate other receptors that are located on the trigeminal nerve. So they per se have nothing to do with the sense of smell. They will then be perceived as stinging. Like, for example, if you have a glass of cognac in front of you and you take a sniff, you can clearly perceive the stinging of the alcohol. But this is another nerve. But this is because usually we experience smell and this stinging or tickling or burning or cooling or whatever. We perceive them together. And so they are processed in the same areas of the brain and they kind of belong together. So if you have a very strong wine with, 15% or something, you will perceive, on the one hand, the flavors from the wine, but we also will perceive the alcohol, the smell of the alcohol, but also the very distinct sensation, trigeminal sensation of the alcohol. And this will all be processed together and belongs together because the flavor perception is the ensemble of the perceptions of the sensations that we have during perception of something in our mouth.
And the trigeminal nerve, is it along our jawline or back under our ears? Where is that?
The trigeminal nerve is a so-called somatosensory nerve. So that's the nerve that is responsible for the innervation of the skin of our face, also of the mucosa. So if you touch your forehead or if you hit your jaw, then the perception that you have is from this trigeminal nerve. So it's responsible for the innervation of the skin, also of the mucosa. If you touch your tongue, you perceive this with the trigeminal nerve. If you go to the dentist, he will freeze either one branch, the lower branch or the middle branch of the trigeminal nerve so that he can do his whatever he wants to do on your teeth or whatever he has to do. So that's all the trigeminal nerve. But this trigeminal nerve, as I said, is also responsible for the mucosa, so for the insides, also for the eye, and allows us to perceive pain, but also allows us to perceive tickling, burning, freshness, cooling, spiciness, and all these different kind of perceptions.
Wow. Fascinating. And that sort of explains why when we have a stuffy nose, we lose our sense of taste. So flavor, I think you've already alluded to this, is not those 5 basic tastes in our mouths. It's the combination of taste and smell working together, right?
Exactly. So in the everyday language, there's often a misconception between flavor and taste. So from a neurophysiological point of view, and I guess it's also from the point of view of wine connoisseurs, the taste is actually only sweet, sour, bitter, and salty. So this is perceived via the sense of taste. Different nerves, again, different receptors. They're located mainly on the tongue, in the papilla of the tongue. Then we have the smell perception that takes place via the olfactory nerve, as I explained before. Then we have trigeminal perception. It's again a different nerve. And then we have other perceptions such as the texture, the coolness, the warmth. We feel liquid, we feel the crunchiness of something. We even hear what's going on in our mouth. We see what we are eating and so on. And all these different sensory modalities together form a unique perception in our brain. And this is flavor perception. So we cannot really completely discriminate or separate them from each other, because what happens in the brain is that these informations that come from different sensory channels are all put together, are processed in overlapping brain areas, and then this unique perception is created. So if you eat a pineapple, for example, you will have sweetness and sourness from the pineapple. You have the aromas from the pineapple. You feel cooling, you feel the acidity that maybe stings a little bit, and so on. And all this together gives you the flavor of a pineapple. So the flavor of a pineapple is all these sensations together.
Wow. So correct me if I'm wrong, but humans have about 400 types of scent receptors. Dogs have closer to 1,000. So what do dogs experience in terms of scent that we can't? And is there anything we can learn wine-related from that?
So, yes, you're right. We have approximately 400 different olfactory receptors, but this number is not exactly 400. Maybe you have 420 and I have only 380, and the 380 that I have don't overlap completely with the 420 that you have. So already from that perspective, our olfactory world is a little bit different. To make this understandable, let's look at the different sense. Let's look at the sense of vision. In vision, we have 4 different receptors. We have 1 receptor for black and white, and then we have 3 receptors for colors, 1 for red, 1 for green, 1 for blue. And with these 4 different receptors, we are able to see all the beauty of the rainbow and the spring and the fall and whatnot. There are some people amongst us that do not have 4 receptors, they only have 3. They are missing one of those receptors. Typically, it's the red receptor. And so they have a hard time distinguishing red and green. And red and green both look for them a little bit grayish. If somebody is colorblind, as this condition is called, it's very difficult for them to imagine how red and green would look like. And the same is for us who are not colorblind. If we have 4 receptors, imagine if we would have a 5th receptor. Some birds have a 5th receptor, how the world would look different. We have no idea. We cannot imagine these additional colors. Now imagine for the sense of smell, we don't have 5 or 6, we have 400. So the dimensionality of our perception is just extremely more vast. But it's even more so for dogs. As I said, you have maybe 420 and I have 380. So already on that level, your olfactory world would be more complex and would definitely be different than mine. But the one of dogs and rats and mice that have way more receptors than we have must be so much more complex, but it's not conceivable for us. So just like we cannot imagine additional colors to the one that we already see.
Is it true, or am I referring to some other sort of science? Do women tend to have more scent receptors than men, or is that taste buds?
It is not so much that women have more receptors than men. This is pretty equal, the number of receptors. Nevertheless, women usually outperform men in smell tests. Or let's put it differently. It's not always that we find sex differences, but if we find sex differences, then usually female participants outperform the male participants. Why this is like this, we do not know. Has it something to do with really the olfactory apparatus being better performing in female versus male? Or is it that women have superior language abilities that is known, and the outcome could be influenced by that because, often these are odor identification tests. And so you have to match a label to the odor. And if you have superior language skills, then this task would be more easily performable. Or has it something to do with hormones because the difference tends to disappear after menopause, or other factors add to those? So it's not entirely clear why this is like this. It could be also a cultural phenomenon. So you may have noticed that I use male and female and men and women interchangeably. We do not know if it's related to sex or gender, because it could be also a cultural phenomenon, because in our societies, women assign a more important role to olfaction. It's typically the mother who is responsible for preparing food, who is responsible for the hygiene of the family, for washing and so on. And this may be then, already given on to young girls and young women, that they are just more interested in that. I can see that in my research. I'm in the Department of Anatomy, and I have a colleague who works on spinal cord injury. And when I look for graduate students, 90 to 95% of the candidates are women, and only few men are there. And at my colleagues, 90 to 95% of the people that are interested in that topic are men, and there's nearly no woman participating. So it's clearly that olfaction seems to be more attractive to women as a subject. When we look for participants for our studies, we always have a much easier time to find women than men. So I think that the topic of smell seems to be more interesting for women than for men. Why this is like this, we do not know. Where does it start? Where does it end? That we don't know. But typically, to come back, if we find a difference in smell tests between the sexes, it's typically the women that perform better than the men.
Fascinating. And certainly just my perception is that the market for perfume is far larger for women, the brands and variations, than it is for men.
Exactly.
So are we better at smelling wine than dogs? Is there something going on there?
This is a very, very interesting and fascinating question. So we just discussed that dogs have so much more receptors than humans, and they also outperform us in many tasks, right? We don't hire a human to sniff around at the airport. We have dogs to do that. Again, it's not all dogs that can do that. And we humans, we can also train different things. We can follow a trace of odors on a field From body odors, we can recognize if somebody's healthy or sick, if somebody is a man or a woman, if somebody's older or young, just as dogs, not as highly performing. But the big difference, if we talk about the receptors, of course, dogs have way more receptors than we have. But the receptors is not the whole story. Because as I said before, the information is then passed on to the olfactory bulb and then to the brain. And in the brain, it's further processed. And we humans, we have one thing that is particularly big and performing in our body, and that's our brain. We have, compared to most other animals, a very big brain, a very high-performing brain. So even if we get less information from the receptors, because we have less receptors, our brain is much more performing and can do much more with this sparse information compared to dogs. We can talk about odors to each other. You can learn something from what I tell you. Dogs do not have this kind of abilities. And it has also been shown that with regards to odors that are related to fermentation, so that's interesting in the context of wine, we humans are particularly sensitive. This maybe have an evolutionary advantage. Imagine our ancestors walked through the savannah. The last antelope has been a while, and there is a tree far down with semi-ripe fruits or ripe fruits. And it was important for our ancestors to be able to smell, are these fruits ripe? If they fall down, if they start to ferment, then it becomes interesting for us. We are very sensitive to these kind of odors, much more sensitive than carnivores that couldn't care less about an apple or something like that. So we have less receptors, but we have a better performing brain, and we can use the information that we get and we can really apply it. And we have developed over the history of mankind, we have developed so many techniques to process our food. Fermentation is just one of it. Fermentation of grapes, of course, but fermentation of wheat for beer, fermentation of milk to cheese. We have developed different cooking techniques, from braising to grilling to steaming to whatever. This is all be done so that we can not only process the food, but also that we can take way more out of the food that we are ingesting. And on the way to this, we have developed also these abilities, sensory abilities with regard to these items that I just said. And wine is, of course, the most prominent of that, where we have developed really superior things. So a dog could never replace a sommelier.
I always wondered why there weren't dog sommeliers.
Yes, because we have to have so much information that is very human related to those abilities that the dog is probably would be better in detecting if there's a cork smell in the wine than we are, but that's not the only thing a sommelier does.
For sure, absolutely. And the dog would also have problems ordering from wineries, and there'd be a lot of complications for the dog.
Yes.
But anyway, so we have, on average, maybe say 400 scent receptors, but we can smell or detect more than 1 trillion different odors. How do we get that many odors from so few receptors?
Again, let's look at the analogy of color. We have 3 receptors for color, but we cannot just see 3 colors. We can see a multitude of colors because we can mix those together. And the receptors that we have, they do not respond to individual odors. So we do not have a vanilla receptor and a rose receptor and a jasmine receptor, because if that were the case, we would indeed only be able to smell 400 different things. But our sense of smell doesn't work like this. These receptors do not respond to individual odors, but they rather respond to so-called functional groups in the odor molecules. So in order to understand it, every odor at the basis is a chemical substance. And if we have, let's say, the odor of coffee, there is 200, 400 different chemical substances in this smell. And each chemical substance has a chemical formula that has some characteristics. And for example, it can be a sulfur somewhere in the chemical formula. It can be an alcoholic functional group, or it can be a double bound, or something like that, a certain carbon chain length, and so on. And our sense of smell, the receptors that we have, they do respond to the presence or not of these physical chemical characteristics of the chemical structures. This means that every odorant that contains, let's say, a sulfur atom in its chemical formula will activate the receptor that responds to this sulfur component, and so on. And basically, we experience our world in 400 different dimensions. This is a little bit simplified, but basically, our apparatus says, of those 400 different things that I'm looking out, are they present or not in the ensemble of odorants that are entering the nose? And this information is then conveyed on to the brain and is then further processed. And this means that if we have odors that are chemically very similar, they will have a quite similar smell. But that's not the whole story. We also have chemicals that are not very similar from a chemical point of view, but they still smell the same. And that means we do not have complete understanding of our sense of smell works. And this is also something that is quite puzzling. For vision, we know for 150 years what are the underlying principles of visual perception. And for hearing, it's also 100 years. For smelling, we lag 100 years behind compared to those other senses. And we have not even understood some of the basic principles of how our sense of smell works. So if we now create a new substance in a, let's say chemical factory, and this substance is volatile and has a certain, is not too big, it's not too small, we can now predict that it has a smell, but we cannot predict what will it smell like. We do not know that yet.
Wow, so much. It's exciting, the potential there for people like you in that field.
Yes, indeed.
Yeah.
Yes.
But, wow. So why are wine aromas or aromas in general so vivid? They can evoke these memories. You talked about going right back to your childhood for those seasonal smells. Why is smell much more powerful than, say, sight or audition?
Before, when I explained how the information is processed, at some point the information will come to the brain, and this then process will become conscious of what's going on. The regions of the brain that are responsible for olfactory processing belong to the limbic system. And these regions of the brain, and that's an exception of the brain, they are not just responsible for olfactory processing, of the processing of smell stimuli, they're also responsible for other functions of the brain, such as emotions, memory, learning, reward. All these functions are processed in the same areas of the brain. And that's an exception, as I said. For example, in vision, it's the occipital cortex that's responsible for visual processing. This cortex, this part of the brain, does not do anything else, just processing of visual information. And so we're very good at it. There's a huge chunk of our brain is reserved for that. But for the sense of smell, it is different. It is part of the limbic system. So when we smell something, the centers of the brain that are responsible for smell processing, but that are also responsible for memories, for emotions, or for reward, are activated by this smell stimulus. And just like we remember a very emotional situation much easier than a very boring one, also a smell can activate those centers, and a smell can trigger memories that have been created in the moment when we smelled this odor that were often emotional and that we remembered. So when we then smell this odor, then the memory to this event will be triggered. And what triggers these odors is very individually different from one person to the next. It could be something for you, it could be something else for me. For me, for example, is burnt rubber. When I was a child, 8 years old, we had somebody lit a car in our backyard. The guy was never found, but I woke up in the middle of the night from, the light from the firefighters and the sounds and the smells. And to this day, whenever I smell the burnt tires that I smelled that night, I was not scared that night. I found it more fascinating for an 8-year-old boy. It's great. The firefighters are there. There's action in the middle of the night. Everybody's awake. So it was very exciting for me. But when I smell burnt rubber today, then I'm directly brought back to this moment. I do not have this effect when I see firefighters or when I hear them, or even if I see a fire. This does not have the effect on me. But every time I smell burnt rubber, sure enough, I will be back 8 years old looking down to this burning car. And the underlying principle is the anatomical identity of the regions that are involved, that are responsible for smell processing, memories, and for emotions.
I can so relate. Like anytime, this is going to sound weird, but anytime I smell a National Geographic magazine, I'm right back in my grandfather's veranda because I just loved the sun was coming in. I'm smelling the magazines, couldn't kind of read them, and I remember him and the fond memories of summer. And it's the weirdest thing. So I love sniffing magazines. Kind of strange.
Exactly.
Yeah.
But this makes it also so difficult to study all this, because the odors that are responsible for this Bruce phenomenon in all of us are different. For me, I happen to also like that smell, but not everybody has the same reaction to these odors. And it's extremely difficult to afterwards find the odors, the precise odors that are responsible for these memories.
Yeah, they're so individual. The limbic system reminds me of an apartment with 4 roommates, whereas whatever that cortex that is processing sight, that's like a single dwelling home. Like it's just focused on one thing.
And I also think the limbic system is roommates that hang out together, do a lot of things together. They mix up between them, whereas the visual system is more like an office building. Everybody has his office and walks out and walks in and does not have too much interaction with the other ones
That's
around.
right. That's right.
But another consequence of this, the limbic system is very poorly related to our language areas. So we have a hard time describing our emotions. We also have a hard time describing smells. So it's really something that is difficult for us. It's much different for a visual input. And this also means that we can modulate much more easily with the expectations. We did studies on that. We can create an expectation, and this can then modulate the olfactory perception that we have. We did this with Parmesan cheese, where we gave our participants Parmesan cheese to smell and told them this is Parmesan cheese. And, they liked it, and they said they would eat something like this. And later on, we came back with the same smell, but we told them now this is dried vomit. And they said, yeah, this is dried vomit. This is gross, would never eat something like this. But it was Parmesan cheese. And we can do this with smells. We cannot do this with images. I cannot tell you this is now an image of Parmesan cheese and show you Parmesan cheese. You say, yeah, I see this is Parmesan cheese. And later on say this is fresh vomit or dried vomit. And you say, no, I can see this is Parmesan cheese. So it's much more modulable and it's much more difficult to describe. And what sommeliers have the ability to do is to have a common language for the smell perceptions that they have. I'm a wine lover, but I'm not at all a specialist. And I can sit with my friends and we drink a good bottle of wine. And then we start to freely associate. This is vanilla or tobacco or berries or barrique or whatnot. And all of us are right because I can say it reminds me of vanilla and nobody can say you're not right. But what the sommeliers are able to do is that they smell the wine, they taste the wine, they can then use precise descriptors that another sommelier that went through the same school is able to pick up and can understand how this wine smells and tastes like without having to taste this wine. And this is what they are training. And this is what the sommelier training is really all about, that they are getting better in describing odors and not so much that they get more sensitive to odors.
Right. So more precise universal language that is consistent.
Exactly.
Well, there you have it. I hope you enjoyed our chat with Johannes. Here are my takeaways. Number 1, why is smell often called the Cinderella sense so underrated in our culture, especially when many luxury products like wine and spirits and perfume are based on it? Johannes explains that there's a myth about us not having as good a sense of smell as other animals, but this has its roots in the 19th century when Darwinian ideas emerged. Suddenly we were just another animal and not this creation of God. So different players, including the Catholic Church, wanted to establish that we were different from other animals, so they looked at what makes us human. Well, that certainly includes our sight, as we can read, language, because we can talk, and it's these senses, audio and visual, that developed for us as humans and how we distinguish ourselves from animals, whereas other senses, like smell, well, animals tend to outperform us. So these became deemed the lower senses and less important for us. Therefore, we put much less effort into understanding how our sense of smell works because that's something that was reserved for rats and dogs and other species. Number 2, even though dogs have twice the number of scent receptors than do humans, why are we better at detecting wine aromas? In the context of wine, Johannes says, humans are particularly sensitive, and this may be an evolutionary advantage. He asks us to imagine our ancestors walking through the savannah. It may have been a while since they ate, so it was important for them to be able to smell ripe, even fermenting fruit. We became much more sensitive to these particular odors than carnivores did, especially those that didn't eat fruit. So while we may have fewer smell receptors, we have a better performing brain to interpret the information we get and then apply it. That's also why we've developed so many techniques to process our food. Fermentation is just one of them. Braising, grilling, steaming, and so on. This is done so that we can get more out of the food, both nutritionally and sensorially, that we are ingesting. So a dog could never replace a sommelier. Well, I know that's a relief to a lot of you, but But of course, I wonder if a dog did become a somm, would it recommend real brands like Chateau La Paz and Doggone Red? Woof. All right. Number 3, what might surprise you about how we perceive the senses of taste and smell? The most central myth, Johannes observes, is that once we have something in our mouths, we talk about taste. But it's actually not taste. Most of what we perceive is olfaction, especially retronasal olfaction, as the molecules enter the nasal cavity from the back through the pharynx and the throat. And what we can taste, sweet, salty, bitter, sour, umami, is actually olfactory perception. And finally, why is the sense of smell so evocative compared to other senses? Johannes explains that the regions for the brain responsible for olfactory processing belong to the limbic system, which is also responsible for other functions such as emotions and memory, learning and reward. This mixed function is not how the rest of the brain works, as each area tends to be dedicated to one task. For example, the occipital cortex is responsible for visual processing and doesn't do anything else. So, when we smell something, we are also stimulating our memories, emotions, desire for rewards, and so on. And that's why we can remember something that happened years ago because it was either associated with a certain smell or strong emotion. In the show notes, you'll find a full transcript of my conversation with Johannes, links to his website, the video versions of these conversations on Facebook and YouTube Live, and where you can order my book online now, no matter where you live. Get holiday shopping, and I'll help you out with the book plates and bottle recommendations. If you missed episode 174, go back and take a listen. I chat about retronasal smell in tasting wine, as well as virtual brands with winemaker Jim Duane. I'll share a short clip with you now to whet your appetite.
Pay attention to what's the flavor coming in, and then what is the flavor as your mouth is closed and you're slowly breathing out through your nose. You can get so much more of an experience of wine if you're paying attention to that. You get more of an expression of the retronasal flavor when you have those secondary and tertiary characters of an older wine opening up. That really builds the retronasal in a big way, especially with your tobacco and your leather and things like that. Or sometimes microbiologically, you can get flavors that come up that way. So if the wine has a little bit of Brettanomyces, a little bit of that horsey, sort of Band-Aidy character, it can be a very nice component of wine, but you don't necessarily smell and feel so much of that up front. But in that retronasal experience, you really can have that evolution of those secondary flavors, those microbial flavors.
You won't want to miss next week when we continue our chat with Johannes Frasnelli. If you liked this episode or learned even one thing from it, please email or tell one friend about the podcast this week, especially someone you know who'd be interested in learning more about how our sense of smell works and how it dramatically impacts our enjoyment, our pleasure of wine. It's easy to find my podcast. Just tell them to search for Natalie MacLean Wine on Apple Podcasts, Spotify, their favorite podcast app, or they can listen to the show on my website at nataliemaclean.com/podcast. Email me if you have a sip tip question, if you'd like to win a copy of Tony's book or Gus's book, or if you've read my book or listening to it. I'd love your thoughts too on this episode. Were you surprised about how our sense of smell differs from the other senses, not just in the way it works, but also in the way it's viewed in our culture? Do you have a story about smelling wine or something else? Email me at natalie@nataliemaclean.com. In the show notes, you'll also find a link to take a free online food and wine pairing class with me called the 5 Wine and Food Pairing Mistakes That Can Ruin Your Dinner and How to Fix Them Forever at nataliemaclean.com/class. That's all in the show notes at nataliemaclean.com/311. Thank you for taking the time to join me here. I hope something great is in your glass this week. Perhaps a wine that smelled divine both on the first sniff and the last one, retronasally. You don't want to miss one juicy episode of this podcast, especially the secret, full-bodied bonus episodes that I don't announce on social media. So subscribe for free now at nataliemaclean.com/subscribe. Meet me here next week. Cheers.